So, questions for me before we start graphing? Number 8. Which section? 3 to 4.
Oh,
18. Sure, let's look at 18. So, for number 18 on 3.4, it says to find the points of inflection and discuss concavity. This will be a good review if nothing else. It gives you the function. Oh, let's see. 4 minus x minus 3x to the 4. So, it wants you to find points of inflection and concavity. What do you need to find points of inflection and concavity? Second derivative, right? Points of inflection and concavity have to do the second derivative. So you start doing your derivatives. F prime is equal to what? Derivative of 4 is 0. Derivative of x is just 1, so negative 1. And what happens here? Negative 12x to the third. But actually, because I'm just finding concavity and points of inflection, I don't really care about the first derivative. I need the second derivative. So I go directly to f double prime. Derivative of 1 is 0, so I don't have to worry about that. Then when I derive this guy, I get negative 36 x squared. So to find your critical numbers, you're going to have to either set this equal to 0 or undefined, but this is never undefined. So your next step is to solve negative 36x squared equals 0. What's the solution to this?
Plus or minus 6.
Minus 6.
Just kidding.
Oh, good joke. So this is connected by multiplication, so we divide it, right? So x squared is equal to 0. And then square root both sides, x still equals 0. So my only critical number, the only point where I could possibly change concavity is that x equals 0. And then I have to test on either side. So I plug in test values on the left of 0 and on the right of 0. Where do I plug them into? For concavity, you plug them into the second derivative. So I'm going to plug in negative 1 here, and I get negative. Right, because this is negative, and when you square, you always get a positive. So we're concave down here. And then when you plug in positive 1, you get negative again. So you're concave down on the other side. So are there any points of inflection here? Because you never change from concave up to concave down or vice versa. And then as far as concavity, you're concave down always. That's a good warm-up for me. The old math juice is flowing. What else can I do for you?
You do one where you have the product rule, like, about 9.
Ooh, okay. So number 9 looks like it gives you x squared plus 1 over x squared minus 1. Here. F of x. X squared plus 1 over x squared minus 1. And then it says, I think the same kind of thing. Determine the open intervals on which the graph is concave upward or concave downward. So, again, since I'm looking for concavity, I have to do my second derivative. I have to do my first derivative first. So, do you guys remember how the quotient rule works?
Mm-hmm.
So the quotient rule says you have to do the derivative of the top times the bottom minus the derivative of the bottom times the top, and then put it over the bottom square. So I'm going to first do the derivative of the top, which is 2x, multiplied by the bottom, minus the derivative of the bottom, which is 2x again, but now times the top over the bottom square. I would definitely try to simplify this before I went on, just because it'll make your life a lot easier on the next derivative if you can clean this up a little. For example, on top, what might I be able to do? You can factor out the 2x, and then eventually you'll get some cancellation inside. Or you can multiply out the 2x and then combine. Either way, it's going to get you to the same place. But I like factoring. So what happens if you factor out a 2x? What's left? X squared minus 1, because you just take the 2x away. Minus, if you take the 2x away here, you get x squared plus 1. So inside, you actually just end up with negative 2. Right? Because this minus x squared and this x squared are going to cancel. And then this minus 1 and this minus 1 are going to give you negative 2. So you get 2x times negative 2 over x squared minus 1 squared. And then you got to do the derivative again. Although that's kind of silly. I'd probably make that negative 4x on top. You have 2 times 8. So prime of x equals negative 4x over x squared minus 1 squared. So we do another quotient rule. F double prime. So we do the derivative of the top, which is negative 4, times the bottom, minus the derivative of the bottom. What's the derivative of the bottom? 2. The 2 comes down, right? Chain rule. 2 comes down, the inside stays the same. Times what? 2x. The derivative of the inside, which is 2x. So that's just the derivative of the bottom. Then what do I have to do? Times the top, right? All over the bottom square. All right. So now we play janitor. Clean this up. So we have negative 4 x squared minus 1 squared. What? I would go ahead and multiply together this negative 2, this 2x, and this negative 4x. What happens when I multiply those all together?
16x squared.
Positive 16x squared, right? 2 times 2 times 4 will be 16. It's positive because you have a negative times negative. X squared because you have x times x. But then you still have x squared minus 1. And the bottom's kind of ugly. What does this simplify to? 4th power, right? Second power to the second power becomes a 4th power. What do you think we can do on top? Rhymes with tractor, starts with an F. Tractor! So there's an x squared minus 1 in both of them, so you can pull out a 4 as well, huh? So let's do negative 4 x squared minus 1. We pulled out the negative 4, we pull out one of the x squared minus 1, which we still have, so we still have 1 left. We pull the negative 4 out of here, so this will be left with a negative 4 still, right? Because negative 4 times negative 4 gives us
Oh,
16.
okay.
Yeah, we still need the x squared as well. We pulled the x squared minus 1 out, but we need this x squared.
You can simplify it.
Yeah, we got some simplification here. Certainly in the parentheses I can collect. X squared minus 4x squared is 3x squared. Negative. And then minus 1. Interesting. That's okay. And then also I have an x squared minus 1 on top, and x squared minus 1 on bottom. So what do you think? So get rid of this and make this a 3.
Yep.
So altogether my derivative will be negative 4 over, negative 4 times 3x, negative 4 times
12x squared plus
3x squared minus 1 over x squared minus 1. This is my second derivative. Whew. Since I'm trying to find concavity, I now have to figure out where this is 0 or undefined. So I'm going to take for f double prime equals 0, I just set the numerator to 0. I guess we can multiply this out. 12x squared plus 4 equals 0. So then you subtract the 4 over. 12x squared equals negative 4. X squared equals negative 4 over 12. What's that mean? Negative 1/3, but when you square root both sides, imaginary,
yeah.
Oh.
right? Because it's negative.
Mm-hmm.
So when you drop that square root in, you're not going to get any critical numbers for this part, because you don't have any real solutions. So then the other one, for the undefined, you have to set the denominator equal to 0. So double prime undefined comes from where x squared minus 1 cubed is equal to 0. Which means if you cube root both sides, x squared minus 1 equals 0. So x equals plus or minus 1. These are not, in a technical sense, these are not critical numbers because if you look at the original function, they're going to give you undefined. But as far as testing for concavity goes, we do need to include these. Right, when we actually test for concave up and concave down, we put negative 1 and 1, and then test in between. But what you want to notice is that you can't possibly have a point of inflection here, because what do you have at 1 and negative 1? Huh? Asymptote. Right? Because your denominator on the original function is 0. So these guys are actually asymptotes. But you can test in between and see what concavity you have. You have to go back to this guy here. Plug in negative 2, and plug in 0, and plug in 2. When you plug in negative 2, this will be positive 4, but then negative 3 times 4 is negative 12, negative 13 times negative 4. The top should be positive. And then the bottom, when you plug in negative 2, should also be positive. 0, f double prime is 0. You plug in 0, that leaves you with negative 4 times negative 1, which is positive. Plug in 0 on the bottom, you get negative 1 cubed, which is, so altogether your negative here. And then when you plug in positive 2, the bottom will be positive, and the top will be negative again, it looks like.
No, it's not good.
Is it? Oh, it's positive, that's right. That's right. I forgot that a negative times a negative is positive. So if you plug in 2, you get negative 12, negative 13 times negative 4. So yeah, they'll both be positive.
So that's a negative 2.
Yeah, same as a negative 2.
That's okay.
Going crazy. So the concavity is concave up, negative infinity to negative 1, 1 to infinity. Concave down, negative 1. How many of you could do that problem if